Let me get zoomed in for you. Okay, at the top, this first piece is not new. Thank you, sir. This first piece is not new. It says describe the intervals or the x values where the function is continuous. Well, it's probably easier for us to figure out where is it not continuous. How do you figure that out? How do we figure out what x cannot be? Set the bottom equal to 0. So if I set the bottom equal to 0, most of us are going to want to go, okay, I think I know where she set it. Let's factor. X is in the front. The only way to get 2 is 2 times 1. What are my signs? Take a hard look. You can't factor it. It doesn't work. Oh, no. I did trick you. So, what are you going to do? How do you solve these? Good guess, because it's on your paper. But how about quadratic formula? Thank you, Bree. So here we go. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, here's the thing. If you just look at the discriminant, the piece that's inside the radical, what do you notice? It's negative. What's the problem with that? So we have an imaginary, couple of imaginary x's is what we have. If it's imaginary, is it going to affect the graph? Is there going to be a hole or a skip or a jump? No. Nope. So what does that tell us? It's continuous from, whoops, sorry, parentheses, negative infinity to positive infinity. That's your interval. Questions on that one? Great. Now we're at intermediate value theorem. Nick was trying to be smart and move ahead. Alrighty. Here's the math words. And this is on page 77 of your textbook, by the way. If f, the function, is continuous, so there's no skips, gaps, or jumps, and it's on the closed interval AB. So we're only concerned from A to B on the x-axis. And this is just a made-up generic picture. It may or may not look like that. And f at A doesn't equal f at B. If you're finding f at something, isn't that a y value? Yes. So this first y value can't equal the second y value. So if you look at your picture here, they don't. I've got 1 point there and 1 point there that's on the function. The y values don't equal each other. And k is any number between those two. So if you look at k, some sort of random number that's between those 2 points. Then there's at least one number for x, they put a c. There's at least one c in here where that y value equals k. So in real person words, it means if you've got a point here and a point here and this piece of the graph is continuous, it had to cross this line to get there. Kind of common sense. You're like, duh, I know that. It's going to show up more and more often here in a little bit, for sure. But just kind of so you know, that's called the intermediate value theorem. Over here, this little picture, I found this one as well online, and I thought it was a good one because you've got an f at A, you have a y value here and a y value here. The function is continuous, but for this one it crosses k, or the y value is k 3 times, and that's okay. We know that it's going to be there at least once. At least once it's going to have to cross k from here to here, but it could be more than once. Any questions so far? You just kind of need to know what the theorem means. There's 2 parts to the theorem. I do want you to label them because we're about to sort of rewrite some stuff. F has to be continuous. That's the first piece. Put a little 1. F has to be continuous. And the second thing that has to be true is that k, that y value, has to come between the other 2 values. So those are the 2 pieces that make that theorem work. So here's what your book is going to say, and possibly an AP test next year. Explain why the function has a 0 in the given interval. First of all, what is a 0? Give me some other words for 0. X-intercept, root, solution. Why does it have a root in the given interval? Well, part of this is about to be a problem because it was 11 o'clock when I typed this last night, and this should say 112. So change this to 112, so this is going to work out much prettier. Well, there are two ways that we can start to explain this. The first one is this continuous between 1 and 2? Is that function continuous between 1 and 2? There's really nowhere that that function's not continuous, right? It's not a fraction, so it's not like x can't be something. So it's continuous. So we're explaining, we're using words. So we say f at x is continuous. F at x is continuous on the interval (1 to 2). In real person words, it means that the function between 1 and 2, all those x's work. The interval, those are x's. So all the x's work from 1 to 2 is what you're saying there. The other piece we have to prove is that k, which in this case is 0, because if we're talking about an x-intercept, isn't the y value 0 every time for an x-intercept? Yes. So in this case, k is going to be 0, and we need to prove that k is between f at a and f at b. We need to prove that k is between f at 1 and f at 2, because there's our interval. Well, f at 1, I've got 1/12 times 1 to the 4th minus 1 cubed plus 4. So -1 and 4, that's 3. That's going to be a 12, 3 and a 12th. F at 2 is going to be 1/12 times 2 to the 4th, my bad, minus 2 cubed plus 4. Two to the 4th is 16. 16/12 would be 4/3, so 1 1/3. Put these together, you have -8 and +4, that's -4. So -4 and +1 1/3, -2 2/3. Is k is 0 between those two numbers? Yeah. What you've just said, you don't need to write this out unless you want to in your notes. What you just said is that on the graph, and who knows what it looks like, but there's a point 1 and 3 1/12, and there's another point that is 2 and -2 2/3. And if the graph is continuous between those points, you're saying, I know that it crosses the x-axis. That's what you've just said. So we're going to say, we said f is continuous on the interval. We've got a little bit of math here, and we say that if k equals 0, k, we can say is between if you want. K is between f at 1 and f at 2. Therefore, put IVT, intermediate value theorem, applies. Therefore, the intermediate value theorem applies. Because those two things are true. It's continuous between those 2 points, between those 2 x's, and 0 comes between the function when we plugged in 1 and the function when we plugged in 2. That's how we know that. Questions? So you're going to have to do some words. AP test, there's words. You got to write some stuff out. Alrighty? Flip your paper. Verify, prove that the intermediate value theorem applies to the indicated interval, and step 2, find the value of C guaranteed by the theorem. So here we go. We got to prove that the theorem applies. Well, what's the first thing we have to know for sure? Is it continuous on the interval? Is this equation, which PS, here's another typo, that's a -1. Sorry. Don't hate me. Is this equation continuous from 0 to 5? Yeah, totally. So we say f at x is continuous on the interval 0 to 5. Are we including 0 and 5?
Yes.
Yes.
How did we know it was continuous?
Say that again?
How do we know it was continuous on it?
Well, this function is always continuous. So it's definitely going to be continuous from there to there.
There's no way to get a 0.
Yeah, there's no way to get a 0 on the bottom. But what if we had an equation, guys, right here, and let's say it was discontinuous at 9? Could we still write this sentence?
Yeah.
Yeah, because the discontinuity wouldn't affect this interval. So just because there is a discontinuity doesn't mean that the intermediate value theorem won't work. Okay? So it's continuous from 0 to 5. Now I need to prove that 11 comes between f at 0 and f at 5. So we need to solve f at 0 and f at 5. So let's see here. F at 0, if I plug in 0, what am I going to get? -1. If I plug in 5, what am I going to get? 29? 25 plus 5 minus 1? 29. Is 11 between those two numbers? Yep, so it's going to have to cross 11 to get from one to the other. So we say, if C equals 11, C is between f at 0 and f at 5. So, the intermediate value theorem applies. So we just proved it. That's step 1. Step 2 says to find the value of C guaranteed by the theorem. Value of C. I think that meant the value at C. I think I screwed that up. I think the value, nope, of C. Nope, that's right, because I'm looking for the x value. So in other words, you might want to write yourself a note that this means find the x. That means find the x. The C is the y value. They want you to find the x that goes with it, basically. So if we're looking for the x that goes with it, how am I going to do that?
Plug it in.
Just plug in your equation, yeah. F at x is now 11. I have to figure out what x, or in this case, they're calling it C. It doesn't matter. You can call it x. They're calling it C. What value of C is going to make that true? So we subtract 11 from both sides. And now I have C squared plus C minus 12. That one is factorable, thankfully. C plus 4 and C minus 3. Because they're calling it C. They didn't call it x. X. Oh, shoot. Yeah, I don't know why I just called it that. C is the... No, F at C. This was F at C. We're looking for C. C is x. They gave you an F at x being 11. We want to find out what that is. That's why. So, C equals -4 and 3. Are we finished? Almost. What's the interval we're looking for here? 0 to 5. So they're not concerned with this value, they just want this one. So 3 is on the interval they asked for. It crosses that little place, or it becomes 11 at 3. That's what they're looking for. Last bit. Find the constants a and b, because they've got extra variables in these, such that the function is continuous on the entire line. Yesterday, when you had a piecewise function and you wanted to know for sure if it was continuous, you would take this number and you plugged it in and you wanted to make sure that they came out with the same value. Do you remember that? It meant that where one graph started, the other one picked up, or where one graph ended, the other one picked up and started. So that's what has to be true for this. We have to make that happen. So if we take that 1 and we plug it in here, f at at 1. F at 1 on the top, what's 3 times 1 squared? 3. Here, F at 1, I'm going to have A times 1 minus 4. Well, I need both of these to come out to be what? 3. So I need this bottom one to equal 3. So A equals 7. You know for sure that it worked. If you take the 7 and you plug it in for A, then plug in your 1s. If you get the same answer for both of them, then it worked. The graphs connect. It's continuous. There's no jump discontinuity. So if I take a 1 and I plug it in, I get a 3. If this is a 7 and I take a 1 and plug it in, I get a 3. It's now continuous. Does that make sense? You guys can see what just happened? The next one is the same deal, it's just a little trickier. You've got a function where it's 2, and then it does something in the middle, and then it's negative 2. We need this graph to connect at this point and this point. So I need an A and B that's going to make that happen. Here's how we get there. At negative 1, I know that that's going to be 2. So what I need is I need for this guy right here to equal 2. So AX plus B equals 2. If I plug in 3 into this guy, I'm going to get a negative 2. So I also need this guy to equal negative 2. So AX plus B is going to have to equal negative 2. Problem is I still have 3 variables on each end here. I think we can do something with the X. What can we do with the X? If I plug in negative 1, see I plugged in negative 1 here. If I plug in negative 1 here, I should also get 2. So let's make this X a negative 1. So now I have negative A plus B equals 2. For the bottom one, I plugged in a 3. So for this one, when I plug in a 3, I should get the same answer. I should also get a negative 2. So I have A times 3 plus B equals negative 2. So I have 3A plus B equals negative 2. Well, I've whittled them down to 2 variables apiece. Now what am I going to do? What do you do if you've got a system of equations you need to solve? There you go. Elimination or substitution. You get to choose. I don't care what you do. I'm going to multiply this whole thing by a negative, and I'm going to use elimination. So I have A minus B equals negative 2. Add going down. I have 4A equals negative 4. So A gets me negative 1. Once you get A, how do you get B? Where? Either one, doesn't matter. So I'm going to plug it in over here just because I've got the space. So I have opposite of negative 1 plus B equals 2. So I have 1 plus B equals 2. B equals 1. And you'll know you're correct if you take these and you plug them both in. And you can get the same answer for the first 2 and the same answer for the second 2. And then you're golden. Questions? Is everybody okay? All right, here's your assignment. It's page 80, I think. Page 80, number 64 to 86 even, and 92 to 98 even. Page 80, 64 to 86 even, and 92 to 98 even.